Hello friends, welcome back to my channel. Today's video we will try to learn about VFD control. How we can control a VFD by the PLC Siemens S7-200 and VFD I am using IG5 company by LS. So let's get started. First of all, I will show you my camera. In hardware I will explain you, and after I will go to the software. This is my PLC which is model Siemens S7-200, and this I'm using for analog which is this blue color wire I'm using for analog output voltage, and black is MPT, and this color wire is I'm using for white color wire is using for minus voltage. And so this is my input uh, are connected with the PLC. Inputs are connected with PLC, and this is our push buttons, and output once I will like to show you. This is my common IM, can see IM, and these two inputs I put for two bulbs which is connected with reverse and forward, and this we will give the command for this one. This is my common voltage, and this is for reverse and forward command. And these three wires we can see in our VFD. Also I make the wiring inside. This is my reverse forward command. As you can see, this is my reverse forward command. Yeah, and this is our analog output command. You can see this one, analog output command, and this black is MPT. This we are not using. This blue wire is plus 10 voltage, 0 to 10 volt, and this minus is for, this white is for minus. So this we will use in our program, and let's get started. So first of all, I will open my Microsoft software, and here we will start for one input address. We will take for any input or close contact we will choose. First we will define our analog input, and after we will design the program for. So first we will choose the move command, move B, and here we will this address any you can give, I0.5 for example we will give, and here I will take the address VB100 for example, and we will move this, but this is sorry, this we have to be choose the W AQW0 AQW0 data register. This will be not accept because of this is we are using the move. This is we have to be choose another move command, move word, because of this is the word data register. Any MW10 for example we will choose for input, and here we will choose this one AQW0. AQW0 is the analog output address of the Siemens PLC S7-200. So which value we will write at the AQW0, after this value will be transferred in our VFD. And so next we will take one more address I0.6 for example, and we will make a multiplication command. But first of all, I will show you how this procedure will be run, and here we will design complete. I will take it here I 0.0 I 1.0. No, I 0.0 can be choose, no problem. I 0.0 we will choose for first input, and first relay will be take I 0.0, and this we will make it little advanced, and here we will make the branch, and here I will take one more relay for our Q Q 1.0. That's this is also we have to be make correction. Q 0.0 we will choose. This will be our reverse command or forward command, for example, and this 1.0 we will use for LED. No, sorry, this is Q 1.0 is in hardware. I am using for reverse command, forward command, and Q 0.0 I am using for LED. So in next row we will choose same as I 0.2, I 0.1, for example, and next we will choose the Q 0.1, Q 0.1 for our forward command, and little make extend and make one branch downside, and here we will take for command of our drive Q 1.1 address we will choose. So, and here we will make the multiplication command in math function, integer math sub, this is multiplication. And multiplication command how we use, I just write here data. After I will explain you, must be watch video at last end. MW20 and MW30 take the data register, and here we will take this one data register MW10. So this is almost our program is now completed. I will transfer this program to the PLC. Click OK. And make the status on. And now this first we will see our in the VFD how much value will be run. This we will put camera. I will put my camera. Little motor also will be shown. So once I will make the camera open, and here I will show you also motor, and this area we will put it here, no problem. We can put it here in this side. Oh sorry, this is the full side coming. Yeah, here I think so. Okay, now you can see it's the showing this 20, and here I write the 20 at the MW20. Because of how we make the calculation, this is the main data register AQW0. When we write it here, for example 20, and I will write here 50 first. 50 when write, and after you can see here is the total 16,000 bits are generated. 16,000 bits equal with 50, and 50 we have to be make multiply, and here also you can see this is the 50. Now frequency is completed. So calculator if we will use for formula which we are using, for example this is our 16,000 bits are completed in our this AQW0 data register. So 16,000 I will write, and you have to be divide it by 15. Here is a 50 frequency running total, so divide by 50. So what's the answer coming? 320 bits. This basically these are running bits. This don't know what's the frequency and how it's generated. This just only understand about this one bits churning. These bits are 16,000 bits. When you make divide by 50 cycle, so this answer coming 320. So 320 bits are equal with our 1 hertz. So which frequency we will write it here after we use this multiplication command, that 50 cycle, and we will multiply with 320, which because of this answer coming 320 is equal with 1 bit. Whenever we will write it here frequency, for example I will write it here 40 for example. So 40, after you can see here is 12,800 bits are generated, and here if I show you frequency, after you can see is the 40 frequency is now generated. I will minimize this one also. This we can little minimize. Oh, sorry, this we will minimize. So I will take it here, this one, and our camera we will open it here. And here you can see now 40 hertz are now running. So as we will change it here, for example I will write the 30. I will write the 30, and you can see here is the change 30. Because of this 30 multiply by 20 hertz, and after this is 9,600 hertz are moved into our AQW0 data register. And as we, for example this is I0.0, when we will make, I will reduce the my frequency, because of this motor is not mounted with perfect mounting, just only for testing. We just write the 20. Now you can see this is the 20 moved, and as I put the forward command, you can see our motor is running in forward command, and I will stop one, and as I give the signal at I0.1, our motor will be go to in the reverse condition. As per scene can be here, we will see, but this is the possibility. Yeah, this is 20, and now if you like to be make it for example 10 hertz, so you can write it here 10 hertz. After your motor will be go at 10 hertz, and as you make it push after your motor will be run in forward direction, and when you put give the signal at I0.1, this is I0.1, when I give signal, after this motor will be reverse run. And if you like to change this value for 15 Hertz for example, so write it here for 15, and after you can find the 15 Hertz, your motor will be go at 15 Hertz. This complete I will show you in my so this complete I show you. Now in PLC also you can see when we give the signal at I0.0, our 15 value is moved into the VFD, and reverse also it will be moved, 15 will be run. And if you like to change the value, so you can put it here, for example 10, we will put 10. How much speed you like to be changed, you can see it now, here is change the 10 speed, so when you push it will be run at the 10 Hertz. So this is reverse and this is forward. And I hope guys you will be understand about this control. If not understand anything, you can send me the message in comment section. I will give you feedback as soon as possible. So thanks for watching. Allah Hafiz.